Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA Physics Paper 1 higher tier from 2024. Question number 4 is on the topic of electricity. This is mainly to do with static electricity. And this is only for physics only, meaning combined science students are not tested on this topic. Figure 4 shows a static electricity generator, which is usually called a Van der Graaf generator. You have the metal dome, rubber belt. The rubber belt moves along between the motor and the metal dome. You have the motor at the bottom. The rubber belt is turned by a motor. As the rubber belt moves, charge is transferred from the rubber belt to the metal dome. That means the metal dome is getting negatively charged, because if charge is being transferred, the only thing that can be transferred is electrons. Figure 5 shows a student touching the metal dome of the static electricity generator. The dome is negatively charged. So, explain why the student's hair stands up on end. The main reason is electrons are transferred from the metal dome to the student and winds up in the air, and each hair is negatively charged, and like charges repel, so they move away from each other. So electrons are transferred to the student, so her hair is negatively charged and like charges repel. The charged metal dome creates an electric field. What is an electric field? Similar to the gravitational field or the magnetic field, it is a region around a charged object where another charged object experiences a force. How does the electric field strength vary as the distance from the charged metal dome increases? Well, it's strongest near the metal dome, so the further you move, the lower it is. Electric field strength decreases. Figure 5 shows the negatively charged metal dome and an earth conductor. So this earth conductor is just connected to a wire, and which is connected to the earth. When the earth dome conductor is moved towards the metal dome, there is a spark between the dome and the earth conductor. That's mainly because electrons are transferred from the metal dome to the earth conductor. The spark transfers 0.6 joules of energy and 2 micro coulombs. Now this micro is 10 to the power minus 6, which means the charge is 2 times 10 to the power minus 6 coulombs. Calculate the potential difference between the metal dome and the earth conductor. Use the physics equation sheet. So we have energy equals the charge multiplied by the potential difference. E equals QV. So energy is 0.60 joules is equal to the charge is 2 times 10 to the power minus 6 multiplied by the voltage. Voltage or potential difference is equal to 0.6 divided by 2 times 10 to the power minus 6, which gives me 300,000 volts. Which of the following changes would increase the distance a spark can jump between the dome and the earth conductor? Decreased charge on the metal dome? No. Decreased electric field strength? No. Decreased electrical resistance of the air? Yes, if there's no air molecules in between, then the distance can actually change, for example in a vacuum. That brings us to the end of this question number 4, and I will see you in question number 5.